Hi, my name is Lily. I'm doing my honours under Dr. Ben Jarahani and Dr. Jack Kochi, supported by the TNQ Drought Hub, looking at evaluating the accuracy of satellite altimetry to measure inland water bodies. Altimetry is a technique used to measure the height of the surface from space, where the radar pulse sent from the satellite travels to the surface of the Earth, bounces back up to the instrument, and this travel time is used to calculate distance. This research is significant because we have seen a major decline in gauge stations over the last 4 decades, in some regions up to 80%, and even where gauges still exist, they only provide information at single point locations and they don't capture a full picture of dynamic systems like braided rivers that will shift and evolve across large areas. This results in major gaps in our ability to monitor fresh water at a time when global demand is increasing and climate change is intensifying droughts and floods. In recent years, satellite missions have allowed us to measure surface water from space, and hopefully this research contributes to the larger goal of improving our ability to monitor inland waters across vast and remote parts of Australia. This study aims to evaluate the performance of satellite altimetry for monitoring inland water levels by comparing satellite-derived elevations against in-situ gauge data, and investigating the utility of these datasets for flood monitoring in complex inland river systems. This study has 12 lake and reservoir sites focused in North Queensland and 3 catchment river sites all draining into the Lake Eyre Basin. These systems have high flow variation because of their long dry periods and intense flooding seasonally. Because of this and the flat landscape, this river forms multiple channels across huge floodplains. Despite the size and complexity of the systems, there are only 12 gauge stations in total. During major flood events, water levels will often rise above the maximum range of the gauges, meaning surface water elevation is not recorded, and in some cases, floodwaters will physically damage or wash away gauging equipment, leading to further data gaps and uncertainty in recorded water levels. The method for this study: satellite ground tracks from altimetry missions were validated in Google Earth Pro to identify overpass locations and selected sites. Corresponding altimetry data was then downloaded. In situ water levels obtained from dam operators and the Queensland Government were aligned with satellite revisit times. Direct comparisons were made by adjusting a common vertical reference, so both datasets were on the same one. Water surface elevation rasters visualized in Python and ArcGIS Pro were used to generate heat maps showing spatial variation in surface water elevation, and further statistical analysis was undertaken in R. This is one example site, Burdekin Falls Dam. You can see the location of the site on the left and the water surface elevation heat map on the right. The comparison of in-situ and satellite-derived water surface elevations on the top and corresponding residuals are on the bottom plot there. You can see the satellite closely tracks the in-situ gauge, accurately capturing seasonal fluctuations in water level. Residuals plotted on the bottom have a mean difference of only 7 centimeters and an RMSE of 0.095 and a strong R squared indicating agreement between these two datasets. Altimetry satellites still have key limitations, including revisit times that can lead to undersampling of flood events. There's still limitations of water body size, errors in geoid models and wet and dry tropospheric corrections, and data availability. So far, SWOT demonstrates strong potential for inland water body monitoring. However, limitations still remain and need to be highlighted. The next step include further analysis across more catchments and writing up the final thesis findings. References for these slides, and thank you so much for watching.